So now we're in Chapter 7, Normal Distribution still. We're in 7.3, which is our standard normal distribution. So here we're looking at a standard normal distribution. Notice that in the center, we have the mean, and the mean is 0. Right here, our mean is 0. And going out, we have our standard deviations of 1, 2, 3, and this one has up to 4 standard deviations. The normal curve, we see that the area underneath here, under 1 standard deviation from the mean, is 30.13. Remember from yesterday that if we go 2 standard deviations, or 1 standard deviation, 1 on each side of the mean, it includes this piece here, along with this piece. When we talked about that yesterday, we said that this whole section is worth 68%. What you have to see that is we have 34.13 and 34.13. If we add those up, we get 68 and a little extra. 68% is what we're looking for, and we have it. So now if we're looking for specific... Oh, Mr. Brooks just walked in and messed me up. So we're looking at now, oh, I already have a clear screen, at the standard normal distribution curve. And if I were looking for a specific value of a standard deviation and not a solid number, 1, 2, 3, I would be looking for my z-value, which we already did earlier this year as well. My z-value equation is going to be equal to x minus mu divided by sigma. Remembering that x is our value, mu is our mean, and sigma is our standard deviation. Now the great thing is we no longer have to use this formula, because if we remember from last chapter we have our Poisson tables and we had our binomial distribution tables. We can have the same thing for our z-value tables. So if I clear this here and I can paste in what our z-value tables are going to look like. Ooh, shrinking it down too far. All right. We have our z-value, and how we look up our z-value, if we're looking for, say, 2.34 to find our z-value, we're going to go to 2, which is down here, and we're going to go to 2.3. And then at 2.3, we're going to look and say, here's 2.3, but I need 2.34, so we need to add another 0.04 to it. So where these line up, don't make fun of my non-straight line abilities, we have here our value. Our z-value is going to be 49.04. So we're going to use these z-values to find out the area underneath a specific part of the normal distribution curve. So if we go back to what the curve looked like, wrong one, guys. Okay, I guess that worked. We go back to what the curve looks like here, and we're looking for 2.34. We want to know what is the area between 0 and 2.34. So 2.34 be about here. So we're looking at all of the stuff, area from that 0 all the way over to here to where 2.34 would be. And that's 2.34 standard deviations. So if we want to know how big this piece is here, we look up 2.34, which I think I remember was 49.04 from our data table that we looked it up in. And if we look right here, this entire area is going to be 49.04. So now I'm looking at a fresh blank slide here. I have a new standard normal distribution currently up, and I want to find out what is the area when z is equal to 0 and z is equal to 1.8. So I'm looking at the area right about, no laughing at my straight lines. This is 1.8. I'm looking at the area here. So to do this again, I'm going to need to pull up the table. So here's the table. And we're looking for 1.8. So we're going from 0 to 1.8. And we have 1.8 listed right here. And then I'm looking at what's the next decimal point. It's going to be 0, so I'm at 1.8.0. And I have this number here as my percentage. So this area that's covered is 46.41%. And why am I using my mouse when I could be using the tablet? Now things get a little bit more difficult if I'm looking at not that. I'm going to need to use that soon, but what I was talking about is I want to be looking at our normal standard curve. And if we're needing to move our normal standard curve, we're pausing. Here we go. I've effectively moved the normal standard curve. Get my pen back. If I am looking at what is the percentage from when z equals 0 to z equals negative 1.41. What is the percentage that's going to be underneath there? So we know when we have z is 0, and now we have negative 1.41, which is about here. And we're looking at the area here. So to find this out, if you notice, even though I made only a small piece here from the earlier one, there are no negatives here. But we know that the same distance from 0 to 1 is 0 to negative 1. And we could do the same thing here with negative 1.41. So we're looking up the z-score for negative 1.41 or 1.41. So we go 1.4 over to the 0.1 and we get 42.07% underneath that area there. So I don't know if I've said this yet. The reason why this is important is because a lot of things fall underneath the normal standard curve, like the height of people. And we could find out what percentage of people are, say, 5'6" out of females, between 5'6" and, say, 6 feet tall. You're thinking, not that many. There are some supermodels, but that's about it. But we can use that to find out where they would fall in the normal curve. Then we can use the normal curve once we have what our standard deviation is. And we could find out what the percentage of people in the world or in the class or in the school would fall underneath that percentage. So if we're looking at a section that is not from 0 over, and we're looking at maybe a section that is in the tail end of the standard normal distribution. If we're looking for here, we have 1.1. Wow. Say this is 1.1. We want to know what is the area from 1.1 into the tail. For this, we need to look at what is the area from 0 all the way to the tail. The area from 0 to the tail is 0.5. Remember, half of it falls on the positive side, half of it falls on the negative side here. So we have 0.5. Half of it is going to fall this side. And if we're looking at 1.1, we can find out what is if z equals 0 to z equals 1.1. And that will give us the stuff I'm going to highlight in blue. That'll give us this piece here. So to find the red piece, we're going to take 0.5, the whole thing, subtract the blue thing. I'm very technical here. Subtract the blue percentage, and we get what the red percentage will be. I'm unable to talk and look up the z-scores in the back of the book, so I just had to flip through it. Sorry about that. Looking it up, I have z of 1.1 is going to be 0.3643. 0.3643. Remembering that that is our blue section there. So we have 36.43% falling in the blue. To figure out what the red part is, I'm looking at 50% minus the 36.43%. Picking up my handy dandy calculator because I don't feel like thinking right now, I find out that 50% minus our 36.43% is equal to 13.57%. Sorry, my notes are all over the place. I can't write small. So this here tells us what our area under the red is. So the area from 0, nope, I'm lying. The area from 1.1 to the tail, so that is 1.1 through the tail, is going to be equal to 13.57%. Next up, we're going to look at what if we're looking at just a small portion of this. So if we're going from, say, negative 2.48 to negative 0, ignore that, 0.83. We map it out and we say negative 2.48 is about here. Deal with it. And negative 0.83 is about here. We're looking at the area between these two portions. This makes it a little bit more difficult because when we look up our z-scores, we're going to have to look at two different ones and not be able to go straight from 0. So hold on a second while I look up these z-scores. So when I look at the z-value of negative 2.48, I get 49.34%. Now that is the distance from 0 to the negative 2.48. The area underneath there, that is the percentage there, the whole thing. But we don't want the whole thing. We need to get rid of this section here that I'm going to highlight in blue. We do not want this piece here. So to get rid of that piece there, we have this whole part, and we're going to subtract what we get for our z-value of negative 0.83. Our z-value of negative 0.83 is 29.67%. Oh, so that's of negative 0.83. And we can take the whole amount, subtract what we don't want, and we'll get the small section here. So 49.34, subtract 29.67. And we take out the handy dandy calculator. And we get it is equal to 19.67. So this section here, which I'll change the color to yet again, this section here gives us 19.67%. So now looking at if we're trying to find it when there's piece on both sides of the mean. If we're looking at 1.5 negative and 2.2 positive. Here's some really fast math. When we have z for 1.5, we have 43.32% as the area in red, and then z equals 2.2, we have 48.61%, which is the blue area in red. When we add these together, we get 91.93%, which is the entire area from -1.5 to 2.2.